Let us discuss today on polar zenithal equidistant projection. So, on the name it is polar projection, that means polar case, and it is on equidistant projection, that means where distance is maintained properly, that means distance on globe remains same on the projection, two-dimensional projection. So that's why it is called equidistant projection. Polar zenithal equidistant projection, it is a two-dimensional plane of projection passes the generating globe at either of the poles. The radial scale along a meridian is truly maintained. Parallels are equidistant on the meridian. That means the interparallel spacing remains same in all the cases. The projection maintains the property of equal distance, while equidistant property are maintained or preserved. It distorts shape, angles and area too. So neither the projection is equal area, it is rather equidistant projection. How the main formula, that means radius of the generating globe is derived, that formula is given here. In figure, xy is the projection plane, PQ parallel is projected at a circle of radius np1, that means here np1, and that PQ parallel is projected as PQ parallel is projected on P1, P is projected on P1, that means np1, but this is the arc distance. To maintain the equal area property, it may be called that np1 equal to arc distance of np. Now we should understand the arc distance. It is not the simple linear distance, rather it is arc distance. Okay, so arc np, angle ncp is equal to, that means that angle ncp, and that np1 is the arc distance of np. That means np1 and np is same, but it is arc distance. So it is one spherical triangle, one side is spherical in nature, and that is curvature. Angle ncp is equal to, that angle is equal to 90 minus phi, because this one is phi, so it will be 90 minus phi. From the segment angle ncp, arc np is equal to cp into angle ncp into radian. C means this is radian. This is one type of measurement. It is not degree, it is radian. Radian means, what is actually radian? Actually when the same distance, that means np and cp and nc, these are all similar, these are all same. So when same radius and same segment of arc is formed an angle, that angle is called a radian. That is the radian measurement, 1 radian. Okay, it is actually pi radian is equal to 180 degree, or 1 radian is equal to 180 by pi. It is 57 degree, like that. 1 radian is equal to, so arc np is equal to cp into angle ncp into radian, because that arc np is equal to, in that case, as all sides are similar, np, cp and nc, arc np and these two sides are actually radial radius, and it is similar. When such angle is created, we can say arc np is equal to that cp, or it may be nc also, cp into the angle in radian measurement, or in simplified form it is r into 90 minus pi radian, 90 minus pi into radian. Thus radius of any parallel is equal to r into 90 minus pi, 90 minus pi radian. Okay. Now what are the mathematical formula? Two mathematical formulas are there. Radius of the generating globe, that is actual radius of the earth, and denominator of RF as of all other projections. Radius of any parallel, that is R equal to 90 minus phi into radian measurement, that we have derived this. What are the construction? To draw the polar zenithal equidistant projection, we should first draw two intersecting cross lines, one vertical and one horizontal, and two cardinal meridians, four cardinal meridians actually, that is four corners, four sides, 0, 90 degree east, 180, 90 degree west. It should be keep in mind that in case of southern hemisphere, 180 degree will be the bottom of the projection and 0 will be in the top. In case of northern hemisphere, 180 degree at the top of the projection, and remaining east and west, these are always same. That means in eastern side it will be east, eastern side it will be east will always be right hand side and west always in the left hand side. With the radii, the parallels are drawn which are concentric circles. All the parallels are actually concentric circles like all other polar cases. With the help of protector, required meridians are drawn which are straight lines radiating from the center of the globe. Okay, by the help of protector this can be done. Okay, the parallels and meridians are leveled and finally ended the task. Now, one workout problem is given here. So 45 degrees south to 90 degrees south, meridians all interval 50 degree, and RF1 is to 90 million. So from this RF we can generate the radius of the generating globe, that is 7.11 centimeter, and the radius of the parallels are 90 minus pi is radian measurement. 1 degree is equal to pi radian by 180 degree. Okay, so from this table we can generate 5.58 centimeter for 45 degree, 3.70 for 60 degree, 1.86 for 75 degree, and 0 for 90 degree. Polar zenithal equidistant projection, in that case pi radian, this one is vital, and how it can be calculated, that is given here step by step. Say for the 60 degree parallel, step 1, 90 minus 60, 90 minus 5, so 90 minus 60 is equal to 30. Step 2, 30 into pi by 180 degree, as pi is related to pi by 80 degrees, so it will be 0.523598775, and last step is the multiplication by R, 7.11 into that, it will arrive 3.70 centimeter. So for the radian measurement we have to multiply the value by pi, and it should be divided by 180 degree, because 1 radian is equal to pi by 180 degree. So transformation from radian measurement to degree value is equal to pi by 180 degree. Okay, now we should concentrate on drawing procedure. Let us start. So first, with the help of scale, we have to draw two intersecting lines. Okay, two intersecting lines. So with the help of that we are drawing the lines, and in that case the value of 45 degree, length of 45 degree southern hemisphere may be taken into consideration in both sides of the central point, horizontal as well as vertical. Then okay, we are taking the measurement, and by this we can draw two lines, 5.58 from the central position. We are taking the radius 5.58 and drawing a circle. Similarly, all other concentric circles are done by taking the respective length. For 60 degree it is 3.72 and for 75 degree it is 1.86. By this we can draw all other parallel. Okay, so concentric circles, actually all concentric circles are drawn, and now we have to take the help of protractor. By using protractor, the points are demarcated 50 degree interval and all are connected to make it a clear idea. Okay, now it is leveled. 0 will be there at the top, as it is the case of southern hemisphere, and right hand side it will be east and left hand side it will be, no, it is not 15 degree, it is 30 degree, because this one was 15 degree, and like that we can so it will be 30 degree. It is polar zenithal equidistant projection. So similar to the now, what are the properties of this projection? It is a non-perspective projection, obviously. The interparallel spacing remains same as it is equidistant projection. It is also an azimuthal projection. It is mostly used to show polar areas within 60 degree north or south. It will give accurate result. The limitations are also there. The tangential scale is increases towards the equator. So this much on polar zenithal equidistant projection. Thank you.